Hello everyone and welcome to today's lesson. We are going to pick up where we left off in chapter 12 and 13 in your OneNote, and we will specifically be looking at the chapter 13 notes and writing the equations for dissociation. So in your OneNote, make sure you go to chapter 12 and 13 and you are in the chapter 12 and 13 notes. Also make sure that you have a calculator out and your periodic table. If you do not have a calculator, you can use the one on your Surface Pro. If you do not have a periodic table, you can always look one up on the internet. There is a helpful resource. If you type in ptable.com, you should be able to find something like this. This can also help you out, okay? And again, if I'm talking about something like charges or polyatomic ions, that is something that you can always look up if you do not have your periodic table. Now, to start, some of you in my classes, we got farther on this topic than others. So please just follow along still and make sure that your notes are filled in. You will be graded for your participation and completion of the notes for today's lesson, okay? Once you are done watching this video, you will have some practice problems to work on. Again, those are for completion as well. So, in chapter 13, we started talking about dissociation and what that is on the molecular level. So I do have a video to show you of what is happening. So let's say we have some water, so that would be our solvent, and we're dissolving something like salt, NaCl, or sodium chloride, and that would be your solute. So let's see what's happening at the molecular level. If we zoom in, so there's our sodium chloride, our NaCl, and you can see that the water, our solvent, is literally breaking it apart, okay? Notice that the partial negative charge on the water is attracted to the positive charge of the sodium, and that negatively charged chlorine is attracted to the partial positive charge on the water. Now, this is an example of dissociation because you are taking an ionic compound and you are breaking it apart into its individual ions. And remember, ions, that is something that has a positive or negative charge. So this sodium right here would be an ion, and this chlorine right here would be an ion. Because you took that NaCl that was a compound and you broke it up into its individual ions, that is dissociation. So let's go back to our notes in chapter 13. So as I just said, dissociation is the separation of ions when an ionic compound dissolves, again, usually in water. Now, ionic compounds, remember, those are things that are made of a metal and a nonmetal. So metals are found on the left-hand side of the periodic table, and nonmetals are found on the right-hand side of the periodic table. And we talked about this in the chapter 12 notes. Electrolytes are actually an example of ionic compounds that will dissociate, and this will be very important later on when we start looking at boiling point elevation and freezing point depression. But for now, let's go back to our dissociation. So you have seen these before in chemical equations, and we haven't really talked about them much. Now we are going to talk about them, and you will be writing them. So the two that we are going to focus on are these two right here. So AQ, that stands for aqueous. This just means that the ions are dissolved in a solution. So again, usually dissolved in water. So that would be the sodium and the chloride. That's why they have aqueous, because they're individual ions that are dissolved in water. And of course, solid, Well, before you put the NaCl into the water, it was a solid, okay? And we use an S to represent that. So let's do another example. So let's take calcium chloride and disassociate that. So we have our calcium, and we have to write the charge on it because it's an ion. Again, this is on your periodic table. If you do not have one, you can look it up on the internet. It is in group 2, so it has a charge of +2. And since it is an ion and it is dissolved in a solution, in this case water, we're going to write AQ for aqueous. Plus, we also have chlorine. That has a charge of -1. It is also aqueous. However, notice that on the side we had 2 chlorides, okay, or chlorines, and we're going to put that 2 in the front right here, okay? Again, if you want to write the 1 here, that's fine, but you do not have to write it. Now, again, going back to chemical equations, that number in the front represents the coefficient, which tells you the number of moles. So if we have 1 mole of calcium chloride, there's 1 mole here, and it disassociates, how many moles of calcium ions will you have? Well, there's a 1 right here, so we would have 1 mole of calcium ions. And as far as the chloride ions, we have 2 of those. Now, in total, if they were asking for the total number of moles, that would be 2 plus 1, which will give you 3, okay? As far as the total number of moles that you got from disassociation, okay? We're going to do some more example problems like that right here. And again, if you need to pause this video at any time, please feel free to do that. If you need to go back and rewatch something or just get caught up writing in your notes. So let's do this one right here. So we have aluminum sulfate. All right, and again, that is a solid, okay? And we're going to put that in water, and it will disassociate into its individual ions. So we have aluminum, and on your periodic table, this would have a charge of +3. It is aqueous because it is an ion that's dissolved in a solution. And we can presume that that would be water. And again, we have 2 of those. So I'm going to put a 2 in the front here. Plus, we have SO4. Something like this is a polyatomic ion, and this you would find on the back of your periodic table. Now, if you don't have your periodic table, you can always just look this up on the internet. And this one has a charge of -2, and this is also aqueous. And again, we have 3 on this side, so I have to put a 3 in the front here. So then it tells me how many moles of each ion do you have. So we have 2 of the aluminum, and we have 3 of the sulfate, which is SO4. And the total number would be 2 plus 3, which will give you 5, okay? So again, we're just identifying and writing the formula for disassociation. And again, those numbers in the front, okay? This tells you how many moles. If we'd like, we can put a 1 right there, okay? Very similar to what we did with writing chemical equations previously in the year. So we're going to do one more example for just writing out these equations. Now this time I have aluminum hydroxide. So that's AlOH3. And again, this is a solid. And again, let's presume that I'm going to dissolve that in water. So we're going to get our first ion, which is aluminum. And as we established in the previous question, that has a charge of +3. And it is aqueous. Now this time we only have 1 aluminum, Okay, if you'd like, you can write a 1 here, but you do not have to. Plus, we have OH, which is hydroxide. This is also another polyatomic ion. Something like this you would find on the back of your periodic table. And that has a charge of -1. This is also aqueous. And notice that we have 3 on this side. So I have to put a 3 in the front here. Again, going back to balancing chemical equations, this is how we're going to balance them. Notice that we cannot put a 3 here, okay, because this is an ion, okay? So you are saying that you have 3 of these individual ions, okay? The reason we have a 3 here is because this is a compound, okay? And again, the compound, and we'll review this more later, we get from doing that crisscross, okay? Aluminum has a charge of +3, OH is -1. If you do the crisscross, this is the formula that you get, okay? Again, just introducing this idea since it's something we're going to talk about more so later. Okay? Now again, how many of each ion do you have? We have 1 aluminum. Okay, imagine there's a 1 here. And we have 3 of the hydroxide ions. Total 1 + 3 will give us 4. Okay, so we just went over how to write the equations for dissociation. You will watch the next video, which will be these next 2 example problems for how to use those equations that you've written to set up a picket fence and solve for a specific number of moles for either the compound or the ion.